Hey there everyone, welcome back to Leetcoding. In this video we are going to solve the problem rank transform of a matrix. The problem description is we are given an m cross n matrix. We have to return a new matrix answer where the answer for row and the column should be the rank of the matrix row and column. The rank is an integer that represents how large an element is when compared to all the other elements, and it is calculated as follows. If an element is smallest element in the row and the column, then its rank is 1. If two elements p, q are in the same row or column, then if p is smaller than q, then rank of p must be smaller than q. If p is equal to q, then rank are same. And if p is greater than q, the rank of p must be greater than rank of q. The rank should be as small as possible. Now this condition is very important. The rank should be as small as possible, otherwise we would have given the any rank to any element, and then we could have given a greater rank to other elements which are greater than this. So now let us consider the example 1, 2, 3 and 4. In this example, if we look at the element 1, so all the other elements which are present in the same row and the same column are 1, 2 and 3, and 1 is at the first position, so the rank for 1 is 1. When we look at 2, the other elements in the same row and same column are 1 and 4. So 1, 2 and 4. 2 is at the second position, so the rank is 2. Considering 3, now other elements are 1, 3 and 4, these elements. Now 3 is at the second position. 3 is at the second position, so the answer for 3 is 2. So if all the elements are unique, we can go to each of these elements and then we can consider all the elements which are in the same row and the same column, and we can sort them and simply find the position of the element. So this is the case when all the elements are unique. This solution would work, but this solution would not work when two or more than two elements are same. For example, let us consider this 4. The elements in the same row and in the same column are minus 47, minus 21, minus 19, 4, 4 and 14. So 4 is at the fourth position, but the rank for 4 is 3. So the rank could be smaller as well depending on the rank of all the other elements which are in the same row and in the same column. So the rank for 19 in this case is 1, and that is why there are only two elements which the rank is smaller than the rank of 4, and these elements are minus 47 and minus 21. The rank of these elements are 1 and 2 respectively. That is why the rank of 4 is 3 in this case. So we have to handle this case separately, and we cannot simply go to each of these elements and take the elements from their row and their column and simply sort and find the answer. Now we are discussing the solution to this problem. So there's another restriction that is given to us, and that restriction is if two elements are same in the same row and column, let us say 42, and in the same row you are going to find another 42. So if the rank of this 42 is x, the rank for this 42 should be x as well. Now because the rank of this 42 is x, the rank of this 42 must be x as well because it is in the same column, and the rank of this 42 must be x as well because it is in the same row. So all these 4 42s are connected. Their ranks must be same. Similarly for this group, the ranks must be same, and it is nowhere said that these two x and y should be same. They are not connected. They could be same or they could be different depending upon the configuration of all the other elements in the matrix. Now, so what we can do is we can go to one of the element. We can find if there is any other element which is same to this element in the same row and in the same column. So we can scan the entire row and the column which is in which this element is present. So you will see that there's another 42. Now we can group them. We can store them in a set or store them somewhere. So we can store their indices. So the index for this one is 1, 1. 1, 1 is in a group. Then we have 1, 5. So 1, 5 is also in the same group. Then we have 3, 5, which is also in the same group. Then we have 3, 3. So all these are in the same group. So the rank of all the element in this group will be same. Next, 5 comma 2 and 5 comma 4. So these are in the same group and the rank for these elements will be same. So now how we can group these elements? So first we can find the element which is in the same group and it is same as 42. So we will look at this element and then we will recursively call the same recurrence to find the elements which is in the same group and the same column, and then we will reach to this, and simply using recursion we can collect all these elements. But this will take a lot of time, and that is why we are going to use a very useful data structure called DSU, disjoint set union find. And those who don't know about this data structure can go to the link, and there's a video on this topic, DSU. In the video there's theory and then there are a few problems discussed on this topic. You can go through the video thoroughly and then come back to the solution and you can proceed with it. It will be very simple once you know DSUs. Alright, so our first task is to group all the elements which are same. So what we can do is we can pick up a row, let us say this row. We can scan all the columns for this particular row. So if two elements are same, let us say this element and the element here, they are same, then we can union them together. Similarly, we can go to all the columns and let us say if these two values are same, then we can union them together. So let us see the implementation parallelly so that it's easier for us to understand. First of all, we are going to create the unions. So we will have few functions. The first function is find. Now find is going to return us the parent. So we are going to create the find function. The find function is going to return us the pair of int comma int. Now this will be x and the y coordinates. Find, and we are going to accept pair of int comma int, and we have to return the parent of this. So let us create a parent of type pair of int comma int parent, which will be a matrix of size. The constraints are 500, so it will be of size 501 501. Then we have a matrix of rank 501 cross 501. Parent of a dot first, a dot second is equal to a, then we can simply return a. Otherwise, parent of a dot first, a dot second is equal to find of parent of a. We are using path compression here. So this is the find operation. Then we have the union operation. So void union, we are given pair of int comma int a and pair of int comma int b, and then we will make a as find of a and b equal to find of b. Now if the rank of a dot first, a dot second is greater than b dot first and b dot second, then we have to make a as the parent of b. So parent of b dot first, b dot second is equal to a, and rank of a plus plus. Otherwise we should do the opposite thing, that is this time parent of A should be B. So A dot first and A dot second, this must be B, and rank of B must be incremented. So this is the union. Now let us try to create all the unions. First of all, we have to initialize the parent and the rank with the corresponding initial values. So int n is equal to matrix dot size, int m is equal to matrix of 0 dot size, now initializing the parent. For int I is equal to 0, I is smaller than n I plus plus. For int j is equal to 0, j is smaller than m, j plus plus. Parent of I comma j is equal to I comma j, means they are their own parents. This is the initial value, and rank of I comma j is equal to 1. Now let us try to make unions. So this is for row. For int I is equal to 0, I is smaller than n I plus plus. For int j is equal to 0, j is smaller than m, j plus plus. And we are creating a map of type int comma pair of int comma int. So if m dot find a particular value, matrix of I comma j, if this value is already present inside the same row, in the same row I, then what we have to do is we have to union them. So union of I comma j comma m of this value. Otherwise we have to make this entry corresponding to the value. Let us create our answer here. Vector of int answer, which is of size n, comma vector of int m with all the ranks as 0 initially. Now we are applying the same logic row column wise. So j is equal to 0, j is smaller than m, j plus plus. Creating a map, then traversing through all the I is 0, I is smaller than n, I plus plus, and then the same logic. Yes, now we are done making all the unions. Now what we are going to do is, so let us say in this case we created all the unions, and we made the parent of, let's say this is the parent in this case, and this is 1 comma 1. So we made the parent of this element as 1 comma 1 as well, and we made the parent of this element as this 42, and this 42 is 1 comma 5, but their representative or the eventual parent is 1 comma 1. So that is why we are going to store all these INJs, all these pairs of INJs at this position. So we will create a matrix which will be of type vector of pair of int comma int. So each cell of that matrix will contain a vector, and that vector will be a union. So each index, so let us say if this is the representative, then there will be a vector at this position which will contain all the pair of I comma j which are in this union. So there are three other elements, so it will contain all the I and j's of these three elements in a vector which is located at this position. So we'll create a vector of pair of int comma int and a matrix of this type. So let us name this matrix as V n comma m. Now we will go to all the elements and then we will find their parent. So auto x is equal to find, we are finding the parent of I comma j, and we will store this I comma j at this parent. So v of x dot first, x dot second dot pushback I comma j. We are collecting all the values which are present inside this union at a particular index I comma j, and this I comma j is the index of the parent or the representative of that union. So we are collecting all these unions together. Now we will be going to each of these unions which are present at some indices. So I smaller than n, I plus plus, and so we are traversing this vector v. So if v of I comma j, so they can be a vector or this could be empty, dot size, if this is equal to 0, that means there's no union present at this position, so we can simply continue. Otherwise what we can do is we can insert this union into a map in a sorted form. So basically let us say we had these two unions and we have some other union, let us say of the value 5. So 5 is here, 5 is here, and 5 is here as well. So this will be a third union, and the representative of this is, let us say, this 5. So this will have some other rank, let us say z. So basically we have 3 unions. So this union will be present, all the elements which are present inside this union will be present at this index, at this particular index. So we will make a map of type int. This int will be the value. So in this example the values are 42 and 5. So these will be the values. Then we will have a vector of unions. This vector will contain all the unions. So let us say for the value 42 we have 2 unions. One is this union and another one is this union. So we have 2 unions for the value 42. So that is why for the value 42 we will have a vector of unions, and this vector of int comma pair of int comma int map m dot pushback v of I comma j. V of I comma j is nothing but a union. So for the value 42 we had 2 unions and we are going to push each one of them. Now let us say that we want to find what is the rank of this 42. So let us consider this 42 and let us see the row and column of this 42. And let us say we know the maximum rank of this particular row and the maximum rank of this particular column, and these are 2 and 3. So the rank of 42 must be the greater of these two, which is 3. But there's another 42 whose rank should be 5. But the rank of all these 42 must be same. So we are going to go with the greatest rank, which is 5 in this case. So we each of the element inside a union, and we will see for each of those element what is the minimum rank that element could have. So in this case, this 42, for this 42 the minimum rank that it could have is 5. So for all the other elements the rank should be 5. Now let us say for this element, if the minimum rank that it could have been 7 instead of 2, so the rank will be 7 for all of these elements. So we have to take the greatest rank. So now we are going to create two vectors, vector of type int row. For row ranks, initially the ranks are, let us say, 0, and column ranks, initially the ranks are 0. Now we will be going to each of the entry of the map. For auto A belong to map. Now these are the vector of vectors, means the vector of unions for a particular value inside the matrix. So for example, in this case there's a value 42, and for this value there are 2 unions, so it will go to each one of them one by one. Now auto L is equal to list of unions, or the vector of unions. It is a dot second. We will go to each of these unions. For auto U belongs to L. Now U is giving us one union. Then we will go to, for each of the pair of I comma j's inside this union, and we will find the maximum rank of all the rows and columns. So let us say we are taking x as a variable, and x is equal to maximum of x comma row of a dot first comma column of a dot second plus 1, maximum of these two values. So this is going to be the answer for this particular union. So now we will be going to all the values again inside this union. For auto inside this, so for auto A belongs to all the values inside the union, and we will make their answer as, so did we create an answer outside? Yes. So answer of a dot first, a dot second is equal to x, and a row of a dot first is equal to x, and column of a dot second is equal to x as well. Why we are doing this? Because we want to know the maximum rank of the row and the column. Alright, so what is the error? So we have corrected all the compilation errors. Now the error is in the logic. So actually the line number 97, so the error is we are adding 1 here, but instead we should add the one outside this bracket. Now let us try to run this. And now it is giving us correct answer. Let us try to submit. Okay, so we got the correct answer. Now we will be discussing the space and the time complexity of the solution. So we are using extra n square space. This is to create the solution as well. And we can see when we are using this map, there could be at max n square or m into n unique elements, and we are pushing them all into this map, inserting them all into this map. So that is why the time complexity is m into n multiplied by log of m cross n. So this is the time complexity. So this is it for the solution. If you like the video, please subscribe to the channel. Thank you.